Welcome in your Real Future channel. Let's start our journey today. Welcome on board. Excel counter. We have a lot of questions. We need to answer all of them regarding Excel counter. What does the Excel counter system mean? What are the main components of the Excel counter system? What is the mechanism of the Excel counter? What are the frequencies used in the Excel counter system? Let's answer all these questions today. Track layout overview. As we explained before, the track divided into small sections to give us the ability to track or follow the train position along the route. There are many techniques used to divide track to sections. The most popular techniques are track circuits (TC), Excel counters, and position detectors and threadles. As we explained before, track circuits, today we're gonna start with the Excel counters. What are the possible statuses of Excel counter? I believe you got it. It's unoccupied or occupied. Let's start with clear or unoccupied. As illustrated here in the picture, this is the system for the Excel counter. We have two Excel counter systems, System 1 and System 2. Both of them connected by signaling cable to the EU or evaluation unit. The covered area between both systems here, called Track Vacancy Detection Section or TVDS. EU is evaluation unit. We take as an example for the system AZS350U. This is Siemens system. A channel 1 and a channel 2, or we can call system 1 and system 2, counting head, it's called ZB43. We have DEK43. This is double wheel detector. We have system 1, system 2, system 1, system 2. TCB. We have two TCB here. This is the track side connection box. ZB43 wheel detector equipment. ZB43 is counting head, which comprises a double wheel detector and the track side connection box. The track section to be monitored is called Track Vacancy Detection Section, TVDS. Excel counter mechanism. What does it mean of Excel counter mechanism? Let's start with these two pictures here. The first picture here illustrated the arrangement of the Excel counter system on the track, Excel counter system 1, Excel counter system 2, and the coverage area between both systems here called TVDS or Track Vacancy Detection System or section. So, system 1 here, we have the counting head and we have the TCB, track side connection box. System 2 we have counting head and we have the TCB as well. So let's start with system 1. System 1 here for the counting head divided into parts. Part 1 and part 2. Part 1 is outside from the track. It's called a transmitter. Part 2 installed inside the track. It's called a transmitter. Between the transmitter and the receiver, there is a magnetic field here and there for system 1, receiver 1, transmitter 1, system 2, receiver 2, transmitter 2, and the same here for system number 2. As illustrated in the picture below here, we have the axle counter head. This is the transmitter, this is a receiver installed inside the track, and this is a transmitter installed outside the track, and this is a connection box. Why we have two systems in each head for R1, T1, R2, T2, and the same here? Because if the train moves from this direction, so the system 1 will start to count the axles cut the magnetic field. So we have axle 1, axle 2, axle 3, and here this is the out system. It should count the same number for the axle in, and here this is the axle out. So the summation for both, if both of them they are equal, like as we have here for axles in and for axles out, this means the track section here is cleared. When the signal, both of those signals sent to the evaluation computer, it will decide that the section already cleared because the in axles equal the out axles, and vice versa. If the train moves from this direction or came from this direction, so this system will start to count the in axles, and this system here will count the out axles. So as illustrated here, this is a receiver system installed inside the track, and this is a transmitter system installed outside the track, and this is a TCB or track side connection box. We have short animation video for the axle counter system. We assume here we have section 1, section 2, section 3, and here section 4. So for the train came from this direction, for sure there is an axle counter system here, and right now after the train passed the axle counter here, we have -4, this is the out ones, and here for sure we have 4. So these signals, both signals, sent to the evaluation unit, which decided that the system became cleared as illustrated here. So the next section here for this system start to counting the 4 axles of the train. So we will have here 4 axles, and when this 4 axles passed over this head here, we will have -4 axles. As illustrated here, after the train passed over this axle counter, so we have -4, and we have at the beginning for in 4 axle. So the EU unit or evaluation unit will decide that the 4 axles in became out from the other out head, so the section will became clear. Right now we have the axle, the train passed over the axle here, so we have 4 axles here and minus 4 here, so the system or evaluation unit will decide that it's a clear section right now. The other section here is occupied section because we have 4 axles in passed over this counting head. Occupied axle counter. Occupied axle counter means that there is axle counted inside the covered area. TVDS is occupied with train axle and red aspect signal is showing up. This is the indoor unit for the EU or evaluation unit. So it have a lot of modules, power module and some other modules. Each one have its own function. Maybe we can explain it later on. And we have system 1 or channel 1 and channel 2. We have here the TCB, trackside connection box. This one has 3 main boards, the back plan port to have all the connections. This is the generator card or generator board. This is band bus filter card or board. For the generator board, we have here multiple potentiometers. This is one potentiometer here to adjust frequency F1, one potentiometer here for adjusting frequency F2, and there is one potentiometer here to adjusting the Fs. F1 or signal frequency F1 for system number 1 is 3.6 kHz. F2 for system number 2 in the counting head is 6.52 kHz. And the transmitting frequency is 43 kHz. We have this device called Bega tester or Bega device. With this device we can test and commissioning all voltages and frequencies inside the TCB by connecting this Bega device and read all the frequencies, inserting the amount we need, and we can adjust from the potentiometer the frequencies F1, F2 and Fs. We have short animation video for multi-section digital axle counter MSD AC. So as illustrated here, when the train comes and we have a red light after passing over the axle counter, then red light for the other signal. After that it's coming clear, it's coming to a green, switch to green light for the other train coming or following the first one. We're done for today. Thank you.